Well, not only is Jupiter the largest planet in our solar system, it's now also the planet with the most moons.
Well, the main thing that you learn from this is that Jupiter, which is, the king of the solar system.
Gazing into the boundless wonders of our universe, one can only be amazed by the colossal stars that are 2,000 times brighter than the sun, swift comets that paint our skies as they fly by, rocky asteroid clusters in space, and the ruthless black holes that have the power to tear planets apart. While our solar system is filled with beauties and a few massive planets, the real intrigue lies deep in space. Scientists are constantly studying other neighborhoods, looking for astonishing celestial bodies and much bigger planets than those in our solar system. Wondering where these massive planets can be found, scientists have just discovered the largest planet in the universe. What is the largest planet in our universe? NASA has spotted the biggest planet in the universe, with a radius estimated to be 1.12 times that of Jupiter, or slightly more, and nearly 500 light-years away from Earth, making it the largest known planet in the universe. This gas giant is an exoplanet named ROX 42b, discovered in 2013. ROX 42b is a direct planetary mass companion to the binary M star ROX 42b, a likely Rho-Ophiuchi cloud complex member. University of Toronto astronomer Thane Curry announced the companion on October 17, 2013. The giant has an estimated mass of around 9 Jupiter masses, depending on the star's age, similar to the masses of directly imaged planets around HR 8799 and Beta Pictoris. To put its size into perspective, it is so big that its gravitational pull holds 80 confirmed moons, though the true number may be much higher. Further to this, Jupiter has a radius of 69,911 kilometers, making it approximately 11 times wider than the Earth's 6,371 kilometers. So in the context of ROX's 42b, if Earth were the size of a 20p coin, Jupiter would be the same size as a football. It is still being determined whether ROX's 42b formed like these planets via core accretion, by disk instability, or more like a binary star. However, the exact planetary definitions could be clearer at ROX's 42b. While it is technically listed as a planet, scientists are split on whether it is a failed star or something else. The truth is hard to tell, and the team at Toronto spent 7 years meticulously measuring the object before announcing that they had found a giant planet. This type of planet is known as a hot Jupiter. Hot Jupiters are a class of gas giant exoplanets inferred to be physically similar to Jupiter, but have very short orbital periods. In our solar system, Jupiter is quite far from the Sun. It's over 400 million miles away. Yet, ROX's 42b is close to its star and has a very short orbital period. That means its surface temperature is probably very high, approximately around 2000 Kelvin to 2150 Kelvin. Hence, the terminology applied to it. Hot Jupiters are easier to detect and measure due to the speed with which they orbit their home star. ROX's 42b is almost certainly a planet, something that scientists cannot confidently say about some other candidates. Measuring the largest planet in the universe. Measuring the dimensions of distant objects in space poses challenges and potential inaccuracies. Because they are so far away, studying directly is difficult. However, we can learn about their properties by observing their effects on their host star. For example, from our perspective, when an exoplanet passes in front of its star, it blocks out some of the starlight. We can calculate the exoplanet's diameter by measuring the amount of blocked starlight. There are other ways to measure the diameter of an exoplanet, but this method is one of the most direct. It can be used to study exoplanets of all sizes, from giant planets like Jupiter to small Earth-sized worlds. When assessing the size of a massive planet, scientists often adopt Jupiter's radius as a standard unit of measurement, considering Jupiter's radius to be 43,411 miles. denoted as 1 RJ. This unit is frequently used when examining the largest planets. It is one of the most effective methods for detecting exoplanets in nearby and distant stars and studying their properties. Planet mass is deduced by observing alterations in planetary velocity as they approach neighboring celestial bodies. Using this data, scientists can infer the planet's density and make informed assumptions about a planet's characteristics. Other galactical contenders. Some candidates for the largest planet in the universe are not believed to be true planets at all. For example, an exoplanet called HD 100,546b is a celestial body with a radius of 6.9 RJ. Yet, this planet's mass and other factors indicate that this exoplanet is actually a brown dwarf. A brown dwarf is an object between a planet and a star. They are larger than typical planets, but lack the mass for hydrogen fusion in their cores. Thus, brown dwarfs are failed stars but remain incredibly large throughout their life cycles. Although several brown dwarfs feature in the catalog of the universe's largest planets, they are not authentic planets. To maintain accuracy, scientists find it more efficient to recognize true planets like Rox's 42b for top honors, considering that this lineup remains subject to change with discoveries. As our understanding deepens through further exploration, re-evaluating celestial bodies may lead to new classifications, challenging previous distinctions between brown dwarfs and planets, the biggest planet in our solar system. Without a doubt, the biggest planet in the solar system is Jupiter. This gas giant weighs over double that of every other planet in the solar system combined. This giant holds 80 confirmed moons in orbit, thanks to its gigantic size and large gravitational pull. In perspective, the fifth planet from the Sun has a radius of 69,911 kilometers, making it approximately 11 times wider than the Earth's 6,371 kilometers. Regarding surface area, Jupiter measures 61,418,738,571 square kilometers, compared to Earth's 510,064,472 square kilometers. The Sun, however, is much larger still. While Jupiter's diameter is around 11 times larger than the Earth's, it is around 10 times smaller than the Sun's. Aside from just knowing how large this planet is, it makes sense that scientists regularly try to understand a lot more about its composition and other properties that lie beyond its gassy layer. It is no wonder several research studies have been conducted to understand this colossal neighbor. Gravity data collected by NASA's Juno mission indicates Jupiter's atmospheric winds penetrate the planet cylindrically, parallel to its spin axis. The Juno mission learns about the planet's interior through radio science. Using NASA's Deep Space Network antennas, scientists track the spacecraft's radio signal as Juno flies past Jupiter at speeds near 130,000 meters per hour, measuring tiny changes in its velocity as small as 0.01 milliliter per second. Those changes are caused by variations in the planet's gravity field, and by measuring them, the mission can see Jupiter's atmosphere. Such measurements have led to numerous discoveries, including the existence of a dilute core deep within Jupiter and the depth of the planet's zones and belts, which extend from the cloud tops down approximately 1,860 miles. Recent discoveries of the remains of cannibalized infant planets in Jupiter's cloud-covered belly have also ended a long-running controversy regarding the origin of the gas giant. The fragments of young planets that the gas giant ate up as it grew to become the massive objects we see today are all over Jupiter. Despite being the biggest planet in the solar system, more needs to be understood about how Jupiter functions inside. Astrophysicist Yamila Miguel, a senior researcher at Leiden University in the Netherlands, says that although telescopes have captured thousands of images of the gas giant's upper atmosphere, these Van Gogh-like storms also act as a barrier that keeps us from seeing what's below. Her research shows that Jupiter was one of the first planets to emerge in our solar system. She went on to say that we do not know that much about how it came to be. The new gravitational data gathered by NASA's Juno space probe allowed scientists to see through Jupiter's shroud of clouds finally. With this information, the team could map out the rocky composition. The massive planet's core showed a shockingly large quantity of heavy metals, and the chemical composition of Jupiter shows that it consumed planetesimals, or young planets, to fuel its rapid expansion. Jupiter began its life by accreting rocky material, just like every other planet in the solar system. Even though today it may primarily be a ball of swirling gas, the planet's rocky core got so thick as more and more rocks were drawn in by gravity that it began attracting significant volumes of gas from a great distance, primarily hydrogen and helium left over from the Sun's creation, to create its massive atmosphere. Two competing theories explain how Jupiter gathered its first rocky material. One holds that Jupiter gathered billions of tiny space rocks, also called pebbles, even though the new study's findings indicate that these objects are more similar to boulders. According to the other theory, Jupiter's core was formed by the absorption of multiple planetesimals, or large space rocks, with a diameter of several miles, which could have acted as seeds for forming smaller rocky planets like Earth or Mars if they had not been disturbed. Nevertheless, it is currently impossible to say which of these theories is true. Since the origin of Jupiter cannot be directly observed, scientists must piece together the puzzle using the data already available, which is a complex job. To settle the dispute, scientists had to build a model of Jupiter's interior. With several challenges already faced in the study of Jupiter's interior due to its lack of a surface and minimal tectonic activity, data from Galileo and Juno were utilized to create computer simulations instead of traditional seismographs. Probes measuring Jupiter's gravitational field revealed surprising concentrations of heavy elements, challenging the pebble accretion scenario. The data suggests Jupiter formed by planetesimals consuming planets, and the simultaneous accretion of rocky material and gas explains its elevated heavy element concentrations. This discovery alters origin narratives for solar system planets, highlighting Jupiter's pivotal role. It indicates a possible planetesimal genesis for gas giants Saturn, Uranus, and Neptune. The findings suggest gaseous planets in other star systems might have formed by consuming planetesimals, impacting their metallicity. As NASA's James Webb Space Telescope explores new worlds, caution is advised in classifying planets based solely on clouded surfaces. The evolving field of planetary study, with ongoing debates on classification, leaves room for future discoveries, challenging existing perceptions. Despite the potential changes in knowledge, Jupiter remains the largest planet in the solar system. Our comprehension of the cosmos will likely become more focused as research progresses. The unpredictability of scientific discovery reminds us that researchers may unveil unexpected findings challenging what we believe to be true. Do you think a bigger planet is yet to be found? Let's hear from you in the comments section. Also, like this video and subscribe to this channel for more. See you soon.